Hello, my name's Tom Sherrington and I'm the co-author of Teaching Walkthroughs, and I'm delighted that Walkthroughs has found its way into the Chiltern Learning Trust Teaching and Learning Framework. In the video series that we've been making, the teachers have been very brave at putting themselves forward to showcase their development through using some of the individual techniques. So they've been taking a technique and modelling how to try to deploy that technique in a class. The teachers are at different stages of development. Some people are very experienced using this particular technique and are showing how it's done very explicitly. And in other situations, you've got someone who's really working on the technique and they're on the journey. And you'll see that across the range of videos. So they're not setting themselves up to be exemplars of how the techniques should be done in some precise way. They're just showing their process as they're working through, trying to work out how to use the techniques. So that's the spirit in which the videos should be viewed. You're watching a teacher sort of being quite vulnerable and saying, well, this is me trying this out. And then there'll be a coaching conversation with me afterwards where we discuss the challenges that they experienced and where things have gone well. So I hope you enjoy the videos. And thanks to all the teachers who took part. It's quite a brave thing to do, as you'll see. But I think they did a magnificent job and the whole process has been incredibly rewarding. So the walkthroughs then, you'll see in the coaching conversations, form the spine of all our conversations. We open the book at the walkthrough that the teacher's working on, and look at each of the different steps to see how well each one of them has gone. And that's an important thing that we're trying to model, that the steps provide a springboard for the conversation rather than an absolute sort of set of rules you have to follow religiously. And again, the teachers did a great job of modelling that in the discussions that we had. So enjoy the videos and I hope you find them useful in your own professional development.
Okay, so today in maths we are going to be adding mixed numbers with different denominators. Okay, so I'm going to talk you through an example first, okay? So here I've got my example, and what I'm going to do is I'm going to partition the wholes and the fractions. So the first step I would take is I would bring my 2 and my 3 over there, and 2 add 3 is obviously 5, we know that, nice and simple, okay? Then I would bring my fractions over here. So I've got a third, add 2 over 5. This is the part that's a little bit more challenging and will require you to really think about the next steps that you're going to take. This is like what I would call messy thinking. So what I would do is I would look at this and I would look at my fractions and I would say, right, I know that they need to have the same denominator to add them. Do we all know that? Fabulous. So I would look at my smaller denominator, in this case it's the 3, and I'd say, can I do anything to that 3 to get to 5 by multiplying it by a whole number? No, I can't. So then I would look, is there another low common multiple? No. So I would cross multiply. What I mean by that is I'm going to times this fraction by 5, the denominator over here, and then I'm going to times this fraction by the 3, which is the denominator over there. Okay, we've done this before. Are we all happy with that stage? Okay, so I would do whatever I do to the denominator, I must do to the numerator. Fantastic. 5 times 1 is 5 over 3 times 5 is 15. Add, and then I'm timesing this fraction by 3. 2 times 3 is 6 over 15. Now they have the same denominator, I can add the numerators. So here, 5 add 6 we know is 11 over 15. And then to get my final answer, I will pull together my whole number and my fraction. So my final answer will be 5 and 11 over 15. Okay, are we all happy with that? Yeah. Okay, so when I've done that, I will review that by looking at my success criteria. Okay, so remember we've digested the information, made sure we understood the question. We partitioned the mixed numbers and we added together the wholes. Okay, we converted the fractions to ensure they had the same denominator. and then we pull it back together. Something to really look out for is that these are proper fractions, okay? This is a proper fraction. If it was an improper fraction, obviously the numerator would be bigger than the... Fantastic, okay? And then I would combine them back together to get my answer. It's really important as well that you check it looks reasonable, okay? Are we happy with those steps for success? Yeah. Wonderful. So, I want to zoom in on my messy thinking. So I told you that this part here was my messy thinking, and I want you to really bear that in mind when you're looking at these 3 questions. I don't want you to do the questions, but I do want you to do is I want you to look at them and I want you to think about what is the same and what is different about these questions when you're going to solve them. I'm going to give you a few moments to talk to about that, on your tables. Off you go. Okay, so that's the same, perfect. Okay.
So the answer will be different still, and also the denominator.
Sit up, talk to your group.
The overall denominator will be different.
They all have holes, so they're all mixed numbers. What's different about them? Really focus on that, because you've got a lot of similarities. What would be different? They all have different fractions. Look at the denominators. What are we going to do each time? Really think about that, okay? Okay, guys, have we got some differences? I want you to focus on the differences. What are the differences?
The first one, you don't need to multiply 1 3/4 by 6. You can just multiply by 3. Because the common denominator for both of them would be 12. Not
Superb. Okay, fantastic. Okay, and I'm going to pull it back. 3, 2, 1. I heard some fantastic answers around the room, so thank you very much for thinking about that so carefully. So firstly, I want a couple of ideas of what is the same about all of these. Can I come to you first? What's the same? Okay, so they both have whole numbers here. Okay, they both have whole numbers. Yeah, we all happy with that one? Tell me something else that's the same. They all have fractions. So when it's got a whole number and a fraction, it's called a mixed number, okay? Good. Okay, and now let's focus on what's different. This is the really important part of the messy thinking. Yes?
The first one, please. You don't need to multiply 1 3/4 by 6 and multiply 2 and 5/6 by 4. The common denominator, lowest common denominator for both of them wouldn't be 24, it would be 12. So you can just multiply 1 3/4 by 3 and 2 and 5/6 by 2.
That was a superb explanation. You can have a house point, okay? So what he was saying there is we don't have to cross multiply like I did with this example here. He has found a lowest common multiple, which is 12. So what would I times 4 by to get to 12?
3.
And then I can also get 6 to 12 by timesing by? 2. Okay, so we've got a difference there with that one. Superb. Can you tell me the difference with this question here?
So since 8 is a multiple of 2, you can just times the 3.5 by 4 to get to the denominator the same, which is 8. So you don't have to times 8 by anything because it's the same multiple.
Perfect, okay. So we only have to change our half there. We have to times 2 by what to get to 8? 4. Come on, guys. We have to times 2 by what to get to 8? 4. Okay, fantastic. So we only have to change that fraction in that circumstance. I know you're going to be fantastic at this, so I'm actually going to get you to get stuck right in. I want you to work with your partner, okay, and I want to hear you using the language, and I want you to solve this question on your whiteboards. Off you go. Really use that method. Okay, so what are you going to do first?
I'm going to take these over here
Yeah.
and add them together. It's 5.
Perfect.
And then over here, so that's 1/3 and 3/4. But we can times them both by each other because there's no common multiple.
Yeah, and do you remember what that was called when we times them by each other? Do you remember the mathematical word?
Cross multiply.
Perfect, well done. Okay, carry on there. How are we doing over here? Okay, what are you going to do to these fractions to be able to add them? We've got a couple of options.
So 3 and 4 both go into 12.
So you're going to give them a denominator of 12. Okay, fantastic. So I've got 1 and 4, which is? 5. Okay, lovely. Okay, what am I going to do as my next step? I need to add the fractions. So I've got a third, add 3/4. Okay, so remember when we were discussing it, we could maybe change one of the fractions, we might have to cross multiply, we might have to find the lowest common multiple. What did you choose to do?
The only way to do it was actually to cross multiply them to get the lowest common denominator.
And
If you do that, I got 1 3/12 3/12 plus 9/12.
okay, so what did you multiply this fraction by, just in case anyone's not too sure?
Yeah. It's 4/12.
Oh, okay, thank you. Thank you for correcting yourself. What did you times this fraction by?
I multiplied that one by 4.
Okay, multiplied that by 4 because it's this denominator here, so it's 4, okay? Perfect. And then what did we times this one by?
3.
Times it by 3. Everyone happy with that step? Yeah. Okay. Now, what do I need to do to finish that line?
You can add them together, which is 13/12.
Okay, again, linking back to my example here, what is different? What is different? Yes.
The numerator is bigger than the denominator.
Okay, therefore it is a
Improper fraction.
improper fraction. Thank you so much. Can I leave that as an improper fraction? No, I can't. And I would say that this is an illegal maths move. Who knows what I must do? Do you know what I must do?
Yeah. So 12/12 would it be a whole? So then there would be one remaining. So it'd be 1 and 1.
Do we agree with him?
Yeah.
Perfect. And how do I get my final answer? How do I get my final answer?
You add the 5 onto the 1/12.
And that would make it?
6 and 1/12.
Show me your thumbs if you got that answer. Absolutely fantastic. If you didn't get that, I'm going to be able to come right over to you now with that independent work. So what I've got here is I've got some challenges. Okay, so I know you're all going to do a superb job because you have just answered that question so well. So now you can move on to the independent challenges. So obviously we've got challenge 1, 2, 3, 4 or 5. And I would like you to choose to start from challenge 1, 2 or 3 and then you can move yourselves on. Off you go.
Hi Kate, it was really good to see you teaching the other day, really enjoyed it. Thank you for letting me come and watch your lesson.
No problem.
And you're looking at the live modelling, which is a really important technique, especially when you're doing maths, and it was great to see you going through the walkthrough. And so we're going to look through the steps of the walkthrough, just a kind of way of evaluating things, but I thought it was really, really good example of it. So you're looking at mixed numbers, different denominators and adding them, so the students got to find lowest common denominator, that type of thing. Mm-hmm. So that was great. She had a nicely chosen example on the board, and you know, you did all the talking and you went straight into the talking, and you actually got quite a nice way of talking through your thoughts, which is, I've worked with teachers where they find that just hard. You know, they want to do it and then talk, but you're sort of able to say what you're doing at the time, and that's quite nice. So I think that's something you've obviously crafted, which is good to see.
Thank you.
And then this is what I loved. You said, okay, this is what I call the messy thinking. And to me, just to use that phrase, it's kind of allowing the students to think, okay, this bit's supposed to be this is a bit where we have to really think hard. And I like that, so that you use that term. And something really explicit, like, I know I need them to have a common denominator, but what is the common denominator? So that sort of stating the problem that you're thinking about and then finding the answer, that was great. And then, of course, getting to the 15th, because it was thirds and fifths, all of that. So that was all nicely done. And then he talked about the criteria and whether you'd kind of met them. So that the idea of having some success, have I achieved it? I suppose part of me thinks that in maths, one of the things to do there is to sort of say, does it feel like about the right kind of answer? Because I feel like in maths, you're trying to sense of scale, and for other types of problems, sometimes you'll be saying, does it seem about right? You know, that's about how big that is, that's about how big that is. So in maths, you kind of have this idea of what kind of answer might I be getting, and is it sort of in the right zone? But generally, the whole thing of checking was nice. And then we went into those examples. And this is a brilliant idea to have different questions. And I thought that was a really clever way of getting them to talk about it. Not do the maths, but are they, what's the same and what's different? And I'll ask you a bit about the rationale for that, but that was all really good. And then, of course, you reach the point of, right, now get on with some on your own. So you just set them up really well, like from the modelling through to this, to the practice. And that was just a nice sequence. So all those things are strong about it. So if we're going to talk about doing it even more effectively, where would you be thinking, okay, if we probe a bit, what would you be thinking, that bit was a bit awkward, or I wish I'd done this, or some of the students still found this hard?
So the bit that I would probe, and I'd break down and like depending on the lesson. So I like to kind of get a feel of what the children understand in that guided practice, and then I could pull a group off for some more guided examples. So if they weren't understanding, like a boy put his hand up and asked me a question about would he cross multiply, or could he find a lower common multiple, I think actually if they're not really solid with that understanding, just pulling them back for another guided example to discuss it and get them to use the language. So kind of almost if going forward and then going back through the steps to build upon their understanding.
Okay, and it was interesting because I don't know what your expectations were, but they seemed to be able to do it more, perhaps better than you might have hoped they would, because you sort of did this quite good decision making where you just sort of, a student gave this really blinding answer about how on one of the examples you don't need to find you don't cross multiply, you just find the lowest common multiple because it was halves and eighths or something. It's like, oh, okay.
Yeah.
So he didn't need more. That student was at least able to go, right, okay, I can crack on.
Yeah, he was ready, wasn't he? And then when he went into the independent work, he chose straight away to go straight on to challenge 3, because I gave them that option, challenge 1, 2 or 3, start there, and then you can build yourself up to challenge 5. He straight away went to challenge 3, and then he only started finding that deeper level of thinking on challenge 4 with the missing numbers, because that was much more challenging. So he then had to go back to the model to be able to take that step to find the missing numbers.
Yeah, that's really interesting. But you left the models up, and this is again, which, I mean, you got the whiteboard, you got the board at the side, and to me that was really strong practice, so that you're leaving the models to be seen whilst they're doing the practice, and that is, not everybody does that. Sometimes people like wipe those off and you're thinking, where have the models gone, and they no longer can see them. So that was all really good.
I think something to take that forward to the next step as well would be making sure it's up on a working wall so that they can see that flow throughout, especially if you've already covered addition of fractions. Adding that onto a working wall for the flow would have been my next thing to think about.
And bigger. I mean, one of the things that I mean, it's difficult, you know, when you're in the back of the class, like the sort of success criteria slide and the scale, it's just I just go a bit bigger, even in the writing on the board, because from the back of the class, you're sort of peering in to see. But that's a tiny issue, really. The main thing, if from my point of view, that I was going to sort of see how you felt about this, was that during the modelling is to check if you're understanding kind of as you go. And a couple of times, there's a kind of a little thing which you occasionally kind of use, which is to say something like, is everybody happy with that step? And do we agree with that? And when you're saying that sort of very generally, you think, well, how do I get an answer for that? If everyone says, is everybody happy? If they say yes or no, you don't really know. So sometimes you said that, but then you thought, oh, hang on a minute, no, I better ask somebody, because in itself saying, is everybody happy with that? And they will go, It's sort of, you know what I mean? So just watch out for that type of, we all do it. It's like a classic kind of teacher thing to ask that sort of almost rhetorical question.
Maybe about some form of assessment, thumbs, or like out of 5 could develop it a bit, do you think?
Maybe, or I would just use more cold calling. So during the live modelling, it's sort of say, stop for a minute and just say, okay, everybody, let's have a think. I've just done that. Why have I made the lowest, how did I work out 15 as the lowest common multiple, or the denominator? Have a think, why is it 15? And then, James, so why do you think I've chosen 15? And it could have been at that point any of them. So you cold call.
Would you do that in that original first stage, or would you leave that until the guided practice to get the children involved? So there's obviously different kind of opinions on that.
Good question. I would do the example just like you did, and then step back from it, and then check for understanding of the one they can see that's correct. So they know it's 15. They're not having to work out 15. They know it's correct. And you would say, so why is it that? Okay, and why is it this? And why didn't I choose 30, or why didn't I choose? So they can, so you're checking for understanding on something that's already done, without the kind of, does everyone get that? Because you're just sampling a couple. So if they all feel it could be them, they're sort of hanging on your words. But yeah, that's why the live modelling that you did was so good, because they can see it nicely unfolding correctly, and that's the correctness which they're learning from. Oh, okay, that's how you do it. Okay, it's only that, and they're seeing it's doable, and that's what you modelled so nicely. It felt, although you said messy thinking, you made that seem sort of, all right, it's messy, but look, we can achieve it.
Yeah.
So that you made it seem sort of doable, which was nice, you know, and that's how maths should feel like. It's not like super hard, it's just a couple of things. And I think one of the best things in that sequence was the fact that you responded to the fact the students were up for it, you know. So you went, okay, we're up, we can do this. And you even said that to them. I think you can do this now. And so that was a good decision. So to focus in on the kind of the action step to go ahead. What do you think? What do you think? Okay, this is the thing I'm going to take away and kind of.
Yeah, I definitely think the like once I've done the model and showed them my thought processing, probing to understand their thought process would be really good to stand back from that model, look at specific elements, especially the more challenging, messy thinking elements, and kind of cold call questions. That would be a really good next step.
Yeah, I think so. And then they're even the least confident students are even more clear, and then the same exact thing would flow. Well, I think that's a great idea. So that's the step then, to do that more checking for understanding just at that exact point, just after you've modelled the thinking, while you're in this stage 3 of it, review the success of your quality of your work. There's that checking for understanding.
Yeah, definitely.
That's great. Okay, well look, I mean, if I say you're gonna, you'll be doing this stuff for a while, but because it doesn't even matter what the subject is, you'll be teaching them more maths. If I drop in, say, our next time, I think it's about 3 weeks from now.
Yeah.
So if I say this first period after lunch on that Thursday, if I drop in there, and then we'll follow up the next conversation after that.
Perfect.
All right. Thank you so much. That was great.
Thank you. That was really good.